First problem, this is a quadrilateral, it's got four sides. So you're not doing it because it's a parallelogram, but because it's got four sides, it's a quadrilateral. That means that you're gonna start with 360 degrees because all quadrilaterals have 360. And then you're gonna subtract away 125, 55, and 36, and whatever's left over has to be your answer. So you get 144 degrees, and that has to be your answer for the measure of angle X. Number two, same thing, it's a quadrilateral, so again, 360 degrees to start with. You can subtract away these three angles. And whatever you have left over, that's what this last angle equals. So you're gonna get y plus 9 equals that 69. And then you're gonna solve for y, so subtract 9 from both sides, you get y is 60. That would be your final answer. Number three, it tells you it is a parallelogram. So for the parallelogram, the rule is that the opposite angles are exactly the same. That means y is already 131. You don't have to do anything else for that. And then the angles that are next to each other, the adjacent angles, are supplementary. So you would go 180, because supplementary means they add up to 180, minus 131. And that's going to give you 49. So that means x is 49. You have to pay attention to which one's x and which one's y. If it's got 8 sides, it's called an octagon, but you have to know everything from 3 to 10. So 3 would be a triangle, 4 would be a quadrilateral, 5 would be a pentagon, 6 would be a hexagon, 7 would be a heptagon, 8 would be an octagon, which is what we have here, 9 would be a nonagon, and then 10 would be a decagon. Number 5 says classify the figure as a square, rectangle, rhombus, parallelogram, or just a quadrilateral. So you're looking for the most specific name. Over here we have 9 and 10, which means we're automatically not going to be a square, and we're not going to be a rhombus, because those need the sides to all be the same. And then rectangle needs 90 degrees, and that's 91, so it's definitely not a rectangle. Since these angles are the same in this direction, the ones across from each other, and that direction across from each other, and the ones next to each other are supplementary, that's the rules that you need for a parallelogram. If it didn't follow those rules, then you would only have 4 sides, and it would just be a quadrilateral. Number 6, we've got these little marks here that are little arrows that tell you that these are parallel lines, which means this is a trapezoid. The rule on the trapezoid was the legs are supplementary. So these two angles that are next to each other on the same leg are supplementary, and then over here these are supplementary. So on the left side you're going to go 2x plus 62 equals 180, and then you're going to subtract the 62, and then after that you're going to divide by 2 to get x all by itself. For the right side of it, you're going to treat it completely separate. You're going to go 3y and 42 equals the other 180 degrees. Subtract 42 from both sides, you get 3y equals 138. And then when you divide by 3, you get y is 46. Number 7, you're going to cross multiply because this is a proportion that has two fractions equal to each other. So 2 times the x minus 6 is going to be 2x minus 12. Remember, you're going to distribute the 2 into both of them. And then on the other side of things, the x and the 4 multiply together, so that's 4x. Now you're going to solve this for x, so subtract 2x to move it to the left. You have 2x equals negative 12, and then divide both sides by 2, and you get x is negative 6. Number 8, asking if they're similar. This is where you set up your fractions and see if they come out to be the same thing. Remember, it's easier if you go small, medium, large. So like 6, 9, and 12 would be the small, medium, and large side of this triangle, and then match that. So small, medium, and large, the 4, 6, and 8 from this other triangle. Reduce your fractions. If they come out to be the same thing, then that means that they are similar. So yes, they are similar. And the scale factor on this would be 3 over 2, which is the fraction that you get that repeats. If they're not the same, then they're not similar, and that means there is no scale factor. This is named the scale factor. Remember, you're comparing triangles, not the top to the bottom. So on the left side, you're going to go 10 for the little triangle's left side, but then the big triangle's left side is not 20. You're going to add them up. 10 and 20 makes 30. On the right side, same thing. The little triangle's right side is 5. The big triangle's right side is not 10, it's 5 and 10 together, 15. If you reduce those and they're the same, like 10 and 30 is 1/3, and 5 and 15 is also 1/3, then that's your scale factor. If they're not the same, then there is no scale factor. Number 10 says find the scale factor. So scale factor on this would be 3/4, because the right side of the big triangle would be 3 and 1, which is 4. Your scale factor, 3/4. When it comes to finding the x though, it's going to be a lot easier if you go the top compared to the bottom, and the top compared to the bottom, and then cross multiply and solve this. So x times 1 is going to be x, and 2 times 3 is going to be 6. So when it comes to x, it's 6. Number 11, trapezoid has a base of 6 and a base of 14. What would be the mid segment? If you draw yourself a little trapezoid just to keep the information, if you have 6 and 14 and you're looking for the mid segment across it, you're looking for something that's halfway between 6 and 14. The way you do it is you average the numbers. 6 and 14 divided by 2, so that'd be 20 divided by 2, and your answer is 10. If you're looking for the mid segment here, you're going to do the same thing. You're going to add 25 and 6 and then divide it by 2. So that'd be 31 divided by 2. It's 15.5 or 15 and a half. Number 13 says find the angle D and F. So for D, this is a trapezoid, but it's also an isosceles trapezoid. So D is going to be the same as C. So the measure of angle D, I just have to recognize it's the same at 60 degrees. When it comes to F, remember that on a trapezoid, going along the legs is supplementary. So to find the measure of F, you're going to go 180 minus 60 is 120, and that's going to be your measure for angle F. 14, doesn't matter how many exterior angles you have, you're always going to start with 360, and then you're going to subtract the angles that you have. So in this case, we have an 80, a 75, a 50, and a 120, and you get 35. So that means that the measure of angle 1 has to be 35 degrees. These are directly from your notes, so you should have been able to find them in your notes. Diagonals of a rhombus are perpendicular. That's the symbol for perpendicular. Diagonals of a rectangle are always congruent. You can use the symbol, the equal with a little squiggly on it. Diagonals of a square have both of those, so perpendicular and congruent. And the diagonals of any parallelogram will always bisect each other. Number 16, what can you say about the base angles of an isosceles trapezoid or a triangle? So if I think about the base angles of an isosceles trapezoid, let's pretend this was isosceles. Base angles would be like this angle down here and that angle down there. And for the isosceles triangle, it would be this angle and this angle. And those angles, the base angles, are always congruent. If you're finding the perimeter, remember you can get the two longest sides and then just double them. So for the perimeter, you can get 4 and 6. And whatever that gives you, multiply it by 2. So the perimeter would be 10 times 2, 20 meters. When it comes to the area, you find the area of the little rectangle separately. So on the left side, you have 3 and 4. Area of this left triangle is 12. And on the right side, you're not going to use 6. You're going to have to subtract away those 3. So it's 3 times 2. This side is 6. That means your area would be the 12 and the 6 put together. It'd be 18. For number 18, this is a triangle. Remember, it's like half of a rectangle, like a sandwich split in half. So you're going to get 7 times 3, which would be the rectangle, and then you're going to divide it by 2. So 21 divided by 2 is 10.5 or 10 and a half. And that would be in centimeters squared. Number 19, parallelogram gets treated just like a rectangle because this triangle on the left could fit right here. You're just going to go 5 times 10 is 50. And it's area, so it's yards squared. Number 20, the area of a rhombus. Remember, the rhombus is like a rectangle that got its corners cut off, so it lost half of its area. Going this way, it's 10. Going the other way, it's 20. And then because it lost all of its corners, you divide by 2. So that'd be 10 times 2 is 200, divided by 2 would be 100. Number 21, the area of this trapezoid, you average the two bases and then multiply by the height. So you're going to go 4 plus 8 divided by 2. And then whatever that gives you, multiply it by 7. So 4 and 8 is 12, divided by 2 is 6. 6 times 7, you get 42. Number 22, for the area, it's pi times the radius squared, which is 50.24. And for the circumference, it's 2 times pi times the radius. So that's 25.12. Number 23, a regular polygon is both equiangular and equilateral. And then the angles right next to each other on any parallelogram are always supplementary. On the back side, or the second page, it says use the area length times width to find the area of the rectangle. So over here you would get the square root of 6 times the square root of 12. And this 12 is 2 times 6. So you have a pair of 6's. Your answer is going to be 6 square root of 2. 6 goes to the outside. 2 didn't have a partner, so it stays on the inside. Over here, you'd go 5 square root of 3 times 3 square root of 3. You have a pair of 3's here, which means a 3 is going to go outside. You already had a 5. You already had a 3. Now with this pair, you have another 3. So that's going to be 5 times 3 times 3. That's going to be 45. Number 3, simplifying this radical expressions. That's where you're going to factor it out. So 108 can be divided by 3, and you get 36. And then 36 is 6 times 6. If you notice you have pairs early, you don't have to keep factoring this out because this is already making a pair. That 6 goes to the outside and the 3 stays on the inside. Number 4, same thing. You can divide by 2. That's going to make 40. And then 40 can be divided by 2. And you're going to get 20. And 20 can be divided by 2. And you're going to get 10. And 10 can be divided by 2. And you get 5. So you have a pair of 2's. You have another pair of 2's. And then you have this lonely 5. So 2 on the outside and 2 on the outside is 4. The 5 that didn't have a pair stays on the inside. And your final answer would be 4 square root of 5. Number 5 says find the value of each variable, write your answer in radical form. So this is a special right triangle. It's a 45, 45, 90. The rule was if this leg is 11, the other leg is also 11, and then the hypotenuse is 11 square root of 2. On this one, it's still a special triangle. It's still a 45, 45, 90, but now it's in reverse. So instead of multiplying by the square root of 2, you're going to divide by the square root of 2. So if this is the square root of 26, you're going to divide it by the square root of 2. Since they're both inside square roots, you can just divide 26 by 2 and you get the square root of 13. Number 7, this is another special right triangle. This is a 30, 60, 90 triangle. The rule was from the hypotenuse down to the short leg, you divide it by 2. So 36 divided by 2 is 18. And then from the short leg to the long leg, you multiply by the square root of 3. So y is going to be 18 square root of 3. Number 8, another special right triangle on the right side. It's a 30, 60, 90. So short leg to the hypotenuse, instead of dividing, you're going to multiply by 2. And then if you look at the left side, it's a 45, 45, 90 triangle. So if that's 7, this bottom leg would be 7, and then this hypotenuse would be 7 square root of 2. Up here on the top right, it says use a diagram to do the trig ratios. Put your answer in simplified fraction. So the sine of A would be opposite over hypotenuse. It would be 15 over 25. Both of those can be divided by 5, so you get 3 over 5. For the cosine of A, it'd be adjacent over hypotenuse. So from A, 20 is adjacent, 25 is hypotenuse. You get 20 over 25, which is 4 out of 5. And then number 3, the tangent of A is opposite over adjacent, so it'd be 15 over 20. If you reduce that, it's 3 over 4. Next problems says find the value of each variable. These you're going to be using SOHCAHTOA. From 40 degrees, x is your opposite and 8 is your adjacent. Opposite and adjacent is tangent. Opposite goes to the top, adjacent goes down to the bottom. Because x is on top, you're multiplying this. So in the calculator, you're going to write 8 times the tangent of 40 and you get 6.7. Number 5, from this 25 degrees, 12 is your opposite. X is your adjacent. Opposite and adjacent is going to be tangent. Angle goes next to that. The opposite goes on top. The adjacent goes down to the bottom. This time x is on the bottom, so we're going to divide. In the calculator, you're going to put 12 divided by the tangent of 25. You get 25.7. And then for number 6, from this angle, x is your adjacent. 16 is your hypotenuse. Adjacent and hypotenuse is cosine. Angle goes next to it. Adjacent goes on top. Hypotenuse goes down to the bottom. You're multiplying on this one. So you're going to put 16 times the cosine of 65, and you get 6.8. For y, pretend x wasn't even there, and you're going to go from 65, that's opposite, and that's hypotenuse. Opposite and hypotenuse is sine. Angle still goes next to it. Opposite goes on top, hypotenuse goes down to the bottom. Again, you're multiplying, so in the calculator, it's going to be 16 times the sine of 65, and you get 14.5. For number 7, it says solve the right triangle, round your answer to the nearest tenth. So that means that you're going to find the missing sides and missing angles. So like over here, we're looking for C. You're going to use Pythagorean theorem. That's an 8 and that's a 10. Those are the legs. So 8 and 10 go together, and then C goes on the other side. That's 64 plus 100. That's 164. And then you square root it, and you find out C is 12.8. Then you're going to use the 10 and the 8. So 10 is going to be your opposite, and 8 is going to be your adjacent. Opposite and adjacent is supposed to be tangent. We don't know the angle, so that's where we're going to be using the inverse tangent. And then you're going to use opposite on top, adjacent down to the bottom. You get 51.3. So A is 51.3 degrees. And then the third part, you're going to be looking for C, but you don't have to go through the sine, cosine, or tangent. You already have 51.3 in your calculator. If you subtract it from 90, ignore the negative sign, you're going to find out what's left over, and it's 38.7. Number 8 is going to be the same thing. So we have 2 out of the 3 sides. We're looking for a leg this time. So you're going to go g squared plus 6 squared equals 15 squared. G squared plus 36 equals 225. This time you have to subtract 36 from 225, and you get g squared equals 89, and then square root it, and you get g is 9.4. For the angles, if we start over here at E, you're going to go from here. 6 is opposite, 15 is hypotenuse. Opposite and hypotenuse is sine. We don't know the angle, so we're using inverse sine, and then your opposite's going to go to the top, and the hypotenuse goes down to the bottom, and you get 23.6. So the measure of angle E is 23.6 degrees. If you want to find G, you don't need to go through all that. You can just subtract from 90 and find out what's left over. You get 66.4. Number 9, you have 2 out of the 3 sides. Pythagorean theorem here, so it's going to be 5 squared and 7 squared equals J squared. That's 25 and 49, and that's 74. Then you have to square root it, and you get J is 8.6. From H, 7 is your opposite, 5 is your adjacent, so we're using tangent. We don't know the angle, so we're doing the inverse of the tangent. Opposite goes on top, adjacent goes down to the bottom, and you get 54.5 for the measure of angle H. For the last angle, angle I, just subtract that from 90, you get 35.5. And we have the last page. If you're looking at AC, that has arrows on it, so it's a line, not a segment, and that is a tangent line, so we can just put tangent. Number 2, again, we have a line, it's got little arrows on it, so from D to E, if it keeps going through, that's called a secant. Number 3 is still DE, but this time there's no little arrows on it, which means it stops. That's a chord. F is at the center. It's called the center. B is right there where the tangent line hits the circle, so that is a point of tangency. And then FE from the center out, that's a radius. Next problem right here. If you look at it, it's just a right triangle, which means Pythagorean theorem again. So it's going to be r squared plus 24 squared equals 26 squared. So r squared plus 576 equals 676. And then you subtract 576 from both sides, and you get r squared equals 100. So that means r has to be 10. Number 8, kind of the same thing. We're still looking at a right triangle. So it's going to be the r and the 8 that are the legs. So r squared plus 8 squared equals. And then over here, the r and the 4 together are the hypotenuse. So r plus 4 squared. On the left side, r squared is r squared. 8 squared is 64. On the right side, r plus 4 squared means r plus 4 times another r plus 4. So this goes back to algebra 1 where you had to distribute and combine like terms. You're going to get r squared plus 8r plus 16. Then the r squares cancel each other out. You move 16 across by subtracting it. And you get 48 over here on the left side. Divide both sides by 8. You find your r is 6. Number 9, the jack-in-the-box problems. Remember, you can make those equal to each other. So 7x minus 6 equals 3x plus 10. Subtract 3x from both sides and you get 4x. Add 6 to both sides, you get 16. Divide both sides by 4, and x is 4. The central angle is the same as the measure of the arc. So if this is 35 degrees, then that means AB is 35. If this is 92, then AE is also 92. From A to C is going right through the center, so that means that this would be 180 degrees. If you already know that from A to B is 35, you can go 180 minus 35. And you find out from B to C is 145. And then vertical angles, if this is 35, then that means this side is also 35, so DC is 35. And then if you know this is 35 and we have 92 from A to E, and these three together make 180, you can go 180 minus 92 and 35, and whatever is left over has to be DE. So this has to be 53 degrees. Now that we have all the little pieces, if it says find the measure of arc DC, it's 35. We already did that one. If it's asking for arc BC, BC was 145. We already did that one. If it's asking for BEC, starting at B, going through E before it hits C, that's everything except for this 145. We can go 360 minus the one angle that we don't want, and we get 215. And then for ED, we already did that one over here. We got 53. So ED is 53 degrees. The last set, if this is a diameter going through the center and it's perpendicular, this is bisected, split directly in half. So these can be made equal to each other. So 9x minus 4 equals 7x plus 10, and then you solve it. If you subtract 7x, you're going to have 2x on the left, and if you add 4, you're going to have 14 on the right, so x has to be 7. Over here, they both have a central angle that is congruent, which means that this little chord is the same as this little chord. So 3x plus 2 equals 17. Subtract 2 from both sides. 3x equals 15. Divide by 3 on both sides. X is 5. Number 3, if these chords are the same, then that means these arcs are the same. 5x minus 33 equals 2x plus 57. Subtract 2x, you're going to get 3x on the left. Add 33, and you get 90 on the right. Divide both sides by 3, and you get x is 30. Remember, at the center, it would have been 120 degrees right here. But since it got pulled back, it got smaller. It got chopped in half. So that means x has to be 60. If a triangle is inscribed in a circle like this, then that means that this diameter is actually the hypotenuse to a right triangle. So x has to be 90. Now that you know that the other angles have to make the other 90. So you can go 90 minus 31. And you get y is 59. So there's your two answers there. Over here, if a quadrilateral is inscribed, the opposite angles are supplementary. So if this is 112, then y is going to be 180 minus 112, and you get y is 68. And then x goes with the 47. 180 minus 47, you get x is 133. On chords that are crossing inside of a circle like this, remember, multiply down the lines. So 4 times y is 4y. 6 times 12 is 72, and then you just divide by 4 on both sides, 18. On number 8, this angle that's directly in between those two chords has to be the average of those two chords. 54 plus 68 divided by 2 is 61. Y is 61. Number 9, again, if you add these two and divide by 2, it's supposed to equal the angle that's in the middle of them. So it'd be y plus 94 divided by 2 is supposed to make 68. Once you have this, to get rid of this 2, multiply both sides by 2, and you get y plus 94 equals 136. And then subtract 94 from both sides. Y is 42.